Yes. Welcome. It's yes, I'll restart this. Very cool to be here, and nice to see so many people came here to listen to us talk. First of all, anyone know what this is? Speak up. It's the National Gallery in Oslo, the old one. It's closed for refurbishing now, I think, so I don't think you can actually enter it. And not to be mixed up with the National Museum in Oslo, which you can actually go and visit now, which I recommend. But again, this is the National Gallery. It's been a host for many famous Norwegian pieces of art. Among others, Vampyr and Skrik, Madonna by Edvard Munch, and many others. And a special thing about artworks is that they're things that have no real use except for looking at, right? It's just things, but they have, or can have, immense value. They're sold for hundreds of millions of kroner. So you'd think that a place like this should be very secure, right? Since you have to secure these things, it's like gold. It should be secure as a bank. So you think they probably have like these really thick walls, right? Good locks, should be hard to break in. Anyone know who this is? Yeah. This is Pål Enger. He's or was a former Norwegian football player. Played for Vålerenga here in Oslo in the 90s. And he's also Norway's most famous art thief. He broke in and stole Skrik from the National Gallery in this way. And he did it several times even, not from this place, but later on. And I want to start with this, since I think, first of all, this is a funny picture, which I like. But also it's there to illustrate that there are really no secure systems, right? That does not exist, and you shouldn't think that the systems you're building are secure. Never say that. So Pål Enger, he broke in through the window, took Skrik and left and was out in less than 90 seconds. And then probably 20 minutes later, there was this security guard who came to look in. Oh, he stole Skrik.
Yeah, so let's say this is a system, right? We have users, we have servers, we have databases. So this might be like the National Gallery, just a system. And what people tend to do is create a perimeter defense. We try to make good locks. We try to make sure that we build a thick enough wall that nobody comes in. But people will always try, and Pål Enger will always be there with his ladder and try to get in. And the thing is, we should expect them to get in, and once they get in, if we just build thick walls, well then Pål Enger can just go to all the rooms in the gallery and steal all the paintings. And in the same way, he could steal all our data if we just have the perimeter defense. So there is no such thing as a secure system. We need to secure all the parts of our system. We need to harden all the parts in itself. Of course, we should also have the firewalls and the perimeter defense, but that's not enough these days. So even this little part here, which might be a class in your code, can be secured. And when every part is secured and hardened, it's very, very hard for the attackers. So doing this is what we call secure by design, domain-driven security, or cyber-secure digitalization.
Yes, and I think this mindset is relatable to the real world as well, outside of software. So we say in Omega Point that we want to be fire engineers instead of firefighters. So in the case where a fire breaks out in one room, that again, you should assume that might happen. You can't always avoid that, but then again, the whole building shouldn't burn down. That's the risk-based mindset. Before we really get started, I just want to mention some people. The thoughts and ideas we will present and dig into today are not me and Eivind's, unfortunately. So we build on others' ideas. So on the left for you is Nassim Taleb. He's a Lebanese-American philosopher and author and former hedge fund manager. He's written lots of books about randomness and risk-taking and how to embrace that, both in when as a human and in finance and others. And on the right you have our two colleagues from Omega Point who wrote the book Secure by Design, Daniel Deogun and Dan Berg Jonsson. And then they are mentioned. And again, this is me. I'm Anders Kofoed. I'm a partner and business area manager at Omega Point Norge. Been working as a system developer and architect for about 10 years now, and the later years more and more with leadership and competence development.
Yeah, and I'm Eivind Kirkeby, and I studied at NTNU, robotics, and then transitioned into IT and learned more and more about security. So now I'm a senior expert and head of cybersecurity at Omega Point Norge. And I do systems development, application security, mostly the defensive part of the application security. I'm more like the guy that Tanya mentioned, the guy that does the defensive stuff, not the penetration testing. But let's dig into this system. So we have our system, and systems, they will always exist for a reason. And the reasons of a system are often the stress factor. So the users need to use the system. The users are stressing our system, and we can't have a system deliver value without that stress. And there are very different types of stress for a software system. We have legal changes, change in user behavior, loss of knowledge, code changes, attacks, lots of types of stress. And systems will react very differently to this type of stress. And we're going to try to find out a little bit about how different systems react to stress. And to do that, we have this graph here. And we're going to measure the performance of the system. And this is just, performance doesn't necessarily mean the request takes 10 milliseconds. It's more about the overall performance, how the systems performs.
It's a sum of many things, right?
Yeah.
Where performance in terms of response time is one, but then again, how it feels and how easy it is to change is also part of performance.
And bugs and how it reacts to bugs. So all in one. And we have stress on the x-axis, and that's stress over time. So we can say, how does the system perform when we apply stress factors, and how does that react to stress over time? Sorry.
Someone hacked your clicker.
Yeah.
So first type of system is a fragile system. And fragile systems, of course, handle stress badly. And it's hard to change the fragile systems. They handle unexpected events badly, and those might bring the fragile systems to a halt. Characteristics of fragile systems are that they're rarely changed, since you don't want to change them, since you're afraid of it breaking. They're usually tightly coupled to other systems, which make them fragile, and again, hard to change. So the graph for fragile looks something like this. It might work when you write the code and exactly when you create it, but over time and with increased stress of different types, it stops working. And we don't want these types of systems, of course, but we've all seen them, and we've all created them. But then the question is, what's the opposite of fragile system? Now you read the title, so you already know it, but what you should answer, or what I wanted to answer, is robust, which is what people usually say, and the term that's most used, I think, robust or resilient. So robust systems are, again, resilient to stress, stands well on its own, and handles expected change and expected stress well. So the performance will stay the same over time, and I emphasize staying the same and expected change. Since, to me at least, or to me the term robust is exactly that. It stays the same, like a brick wall, right? With like increased stress, it keeps going, but it doesn't change. So the line might be something like this. It stays the same, but then at some point the brick wall breaks, right? And then I ask, are these two graphs opposite or the inverse of each other? I say no. It doesn't look like it, at least. So what then is the actual opposite of a fragile system? Again, from the title, you already know it. That's what antifragile is. And an antifragile system, it benefits from stress. So with increased stress, the antifragile system becomes better. And it might sound strange, but I will explain more. Again, remember that the systems we're talking about here are not like one server or one application. It's the sum of parts. So it's the systems we build are, from the first illustration Eivind showed, it is servers and databases and all that, but it also is people, users, it's everything, right? And that's what you want to make antifragile. And so what examples from our real life, or the best example is probably our human body, which is an antifragile system. So we get sick, but then again we get stronger from being sick. That's an antifragile reaction. And it also works the opposite, which I think is a very interesting thing. So many of you probably noticed that during the pandemic. So we went like years without being sick at all, or being like in contact with stress. And then when we got back to our normal lives, we were out for years again, right? Or at least I was. And I think the same is actually true for software systems. So if you have a system that's never changed, so it's working, but you don't change it, you don't apply stress to it, I think the performance of that system most likely will go downwards. So when you want like 2 years down the road, you actually have to change it, that will be very painful. So the graph looks something like this. It actually goes upwards. But if we zoom into that graph, it's not exactly like that. It's probably more like it goes up and it goes down. It's like a zigzag pattern, right? And the important thing there is that the part where it actually goes down when you take the hit, that's small enough so that when you go up again, that's asymmetric. So that's why we call these small up and downs patterns, which I have not in the drawing. That's like asymmetric reactions. So you get sick, but then you get stronger again. So again, then it's important that we don't go bankrupt when we get the kind of the downward slope. Okay, so how can we build this type of anti-fragile software systems, Eivind?
Yeah, well, this type of stress factors might find bugs. So, and when you take the hit, you fix the bug, and then you get stronger, right? So let's say these are just bugs, and we have triangle bugs. These are the normal bugs, and we coined the term a security bug, a bug that's related to something dealing with security. And what we want to make is design patterns to cover these bugs, right? We want to make code constructs that make sure that those bugs doesn't happen, because we don't want to learn all the stress factors in production, right? We want to test our system. We, of course, want to pen test our system, but we can start much earlier and try to think about stress and try to think about how we can deal with that. And creating such design patterns might cover bugs. So let's say we have a design pattern here. We are thinking about these bugs and we're covering those, but side effect of that might be that we cover these security bugs also. So, but what we like to call a secure by design pattern is patterns that are trying to cover security bugs, but they might also cover normal bugs. So a secure by design pattern is just a pattern that we try to apply to cover security issues.
And as you will see, many of these patterns are patterns you already use. It's not like the secure by design patterns are new patterns or something special. It's things you probably already do, but that we will show that they actually are working towards more secure systems.
Yeah, so of course managers will always say security is our top priority. It's very popular to say, but what do they really mean by that? Because security doesn't earn you money, it can just lose you money, and it's always excessive until it's not enough, and then you take the hit, and managers always think about money, at least most often. So, but if we try to think as developer, what does it mean to prioritize security?
Yeah, so one traditional approach or a naive approach might be that, okay, now that security is the #1 priority, then all developers have to know all this security stuff, right? Have to know OWASP, you have to know all these types of vulnerabilities, you have to keep yourself updated on 0 days or CSV and stuff like that. And then your brain starts to melt, right? Since you're still supposed to know all the syntax and all the programming languages and the patterns and stuff like that. And it becomes too much. And this is the reason why many developers, at least used to think that security was kind of difficult and intimidating, and you didn't want to touch it, and you want to instead like give it to the experts. So a stupid, simple example might be something like this. So this is a class, just a user class, could be anything. And there's some string in there, and then you could think that, okay, this class might be used in some view model, and then there might be some cross-site scripting vulnerability possible here, right? And then, okay, I'm a developer, and now I have to think about these things. So what do? Then I have to create some method to actually validate for this, right? So I create this method. And the problem with this is that after a while, you will have lots of these methods, right? You will just have chains of different methods checking for specific security stuff. And first of all, you have to remember to do it all the time, and everyone have to remember to do it all the time. And it clutters the code. So quickly you will not be able to see what the class is actually supposed to do or what it actually represents. You will only see security stuff, which might be good. You can show it to your manager. I've created here's a lots of security, but again, hard to maintain. So the secure by design approach is instead to turn this around. So let's not think about the explicit security stuff, but instead make sure that the class only accept what it should be and it looks how it should be. So here, okay, we say that, again, this is a very simple example, but the username should be of this length and only contain these characters. And then, as a side effect, it will actually protect against the same things than if you just checked for the curly brackets and disallowed that. So we advocate for this approach instead, and this is much more natural to developers, and it's it creates much better code as well. And I think interesting thing about this as well is that we as developers, we like to create beautiful code, right? You want it to look good. So hands up if you think that same. Sometimes you say, okay, this doesn't look good. It probably works, but it's not beautiful, right? At least that's how I am, and I might spend lots of time just and we discuss things like tabs versus space and stuff again, or just how many lines it should be between methods. And thing with that, that's very hard to sell. So if you're a consultant, or even if you're not a consultant, it's like you say to a manager, I need 1 more week to finish this since I have to make it look more beautiful, right? That's a hard sell. But if you can say that instead, by doing that, I will also make the code more secure, then it's yes, then that's good, go do that. Yeah, so that you can use. So just take a bit further. Now I just took the string out and created a specific class for the username containing this logic, which then can be used something like this. So now we don't have a string username, we have a username class for the username. So username here is a very simple example of what's called a domain primitive, which is the most bare bones, simplest secure by design pattern we have. This is from domain-driven design. It's nothing we came up with. A domain primitive or a value object from domain-driven design is a mutable object that can only exist when the value is correct. So when you meet or when you find some class like this in the code, you can also always assume that it is correct. You don't have to evaluate it. And there are like the smallest building blocks when we model reality. And we will give some more real examples soon. Yeah, again, so this is then this is a value object then. And another thing about this is that it not only makes like the code you write now probably more secure and it's better design, it also makes it harder to do mistakes later. And I think when we write software, like there should be a quite large empathic factor as well. So you don't only write the code to work now and for you to be done with your work. You create it for others to change it down the road. And by doing good design, depending on that, what that is, of course, you will avoid mistakes by others as well, which I think is maybe even more important. And just to illustrate that, this is my drawing of a system. And the boxes down here are maybe like some type of sub-components. It might be classes within classes or whatever, I don't know. And when a request comes in, so through some web API maybe from a computer, it will enter, and then you will ask, okay, but can't I just validate here? That's what I normally do, and don't bother with these value objects and stuff like that. And of course, you can do that. That's fine. But I will claim that I don't really care if the data is correct up here inside the green circle. That doesn't matter at all, most of the time. Since the data will pass through your system, and you might not have created all of these components. Most of the time you have not. And then what really matters is that the data is correct down here. Or when it's read up again, it's probably even more precise. But that's what's matter, right? And then, of course, do validation, but if you as well apply value objects or domain primitives, you will know that it will be correct all the way down. Of course, if it's used. So you can always cast out of it, of course, but then, yeah, this is at least better. Since here we know that it will be correct when it's saved, and even when it's loaded back from the database. So if somebody cluttered the data in the database, it will fail when you instantiate it from the database as well, which is good.
Yeah, but usernames might not be the best real-world example. It's just a string of characters that we use in computer systems. So let's try to imagine a more real-world example. For example, what we call postkode or postal code in Norway. What you most guys would call zip codes, I guess. But those are 4 characters in Norway, and they can contain leading zeros, and it should be just numbers. And when I log into the bank, I can get this form where it's like, is this your address? Can you confirm this? And then suddenly it happens, I get like, is your postal code 356? No, it isn't. It's 0356, right? So this has actually happened to me. The 0 is gone. And why is that? The integrity of the data is broken, right? Let's see a simple example on how that can happen. Can you see the problem here with the zip code? Yeah, it's an integer, right? And when we sum it up here, the leading 0 disappears. And this is a very normal thing to happen. But this code builds fine But there's actually another error here, another bug. Can you see it? Well, can you see it?
Yes, I wrote the example.
Yeah. So the parameter order is wrong, right? The name is now my address, and the address is now my name.
So who has seen that bug where you have lots of strings in a method and it's been changed when refactored?
Yeah, it's so easy to do.
One has seen it at least.
When you suddenly have more than 3 strings, you have to check really carefully, and probably your test run okay because you just inserted dummy string and everything's okay. So these are very normal bugs. And but let's jump back to the postal code. What we claim here is that a postal code is an integer, right? And to claim that, we think is kind of crazy, because this is the definition of an integer. It's very mathematic, and I'm not going to go through it all, but the thing is, this is a definition of a number, and saying that a zip code or a postal code is that doesn't make sense to us. And this wouldn't keep the integrity of the data correct. So what can we do? Well, we can create these domain primitives or value objects and make sure that the logic within that class make sure that this leading 0 is okay. It validates that it's just numbers for characters. You can override it with a toString method to make sure that the 0 is kept correctly. And you can encapsulate all that logic into a real-world building block, which you might call postal code, like here. So, and when you sum it here, somehow, then you will get the correct value. And now also, this won't build, because now I have 2 domain primitives, address and name. And this one doesn't take an address in the first part. And even though name and address might have some of the same rules, this gives very much value, because a name isn't the address, it's 2 very different things. And now we have created these building blocks that also gives us stronger type safety.
Yes, so as Eivind said, postal code is changing. It's an integrity problem, of course, which is a security problem, but it's not that big of a deal, maybe. What's a bigger deal is money, which is where I always recommend using domain primitives without any doubt. So problem is that if you're allowed to add kroner and euros, in example, that's a bigger problem than Eivind's postal code changing, right? And it might be good or bad, depending on if you're the customer or the bank, of course, and which currency you actually want to use. But it still will be a much more critical bug. So you can use domain primitives to model stuff like that as well. So here is a more complex example where you have more properties as well. So instead of using a decimal and maybe some string on the side, you say that money is actually a currency and a value, the combination of those 2. And then you can actually enforce it. So it's not possible to make those kind of mistakes, since you can also make or model operators. So then you can say, okay, you're not allowed to sum to money or with different currencies, which is a very strong tool. Okay, so this was examples of integrity and secure by design. One secure by design pattern you can use for integrity. We also want to focus a bit on confidentiality and how you can model things there in a secure by design way.
Yeah, so in the description of this talk, we promised that we would show you how we can secure a API request pipeline. So we'll just imagine an API request here, and let's just get a very simple API request. There are things you can do here to make it better with contracts that are returned out, but this is the bare bones simple example. Well, we have some service that gets patient records, right, by ID. And we have an endpoint, and we get an ID from the route, and we return either if we find a record in the database, it's okay, but if it's null, then it's not found, right? So we have an endpoint with no security added at all. So how do we secure this? Well, one way is to think of a step approach. And first, we want to validate that the request is correct. It's very easy to start with validating the data is correct or the authorization, but first we want to know, is the HTTP request well formed? Is the headers well formed? Is the content type okay? And this is often done by the framework, not always, so keep this in mind. But then we want to validate that the access token is correct if you use token-based authentication, which I hope you do. And then we transform this token into a permission model. You can do that and in the system. And then we validate that the data in the actual request is correct, like validating the body of the post request maybe. And then we validate the permission to execute the operation, or what we call functional level authorization. And then we do permission to query or change data, and that might be object level and property level authorization. But a lot of these steps here, I think people kind of tend to do correct and know what to do. They know that they need to validate the token. They know that they need to do everything up until the endpoint. But where people tend to mess up is these two last steps.
And just so that we've said it, so authentication, of course, is about who you are, which we will not focus on. Eivind can give a separate talk about that and only that. And authorization then is, as Eivind just said, is about what you're allowed to do. So what you're allowed to access, what you're allowed to read, and what you're allowed to change. And we will focus on the latter. And why do we want to focus on that? This is OWASP top 10. And in the top 5, 3 of them are related to authorization. So if you as a developer, again, I had this list of security things I recommended you to not learn. If you should learn one thing or focus on one thing, then we think authorization is probably one you should spend time on at least.
Yeah, so let's get back to the different level, and it's important to know that authorization isn't just one thing. It is different level with increasing specificity. And we start with a functional, and that's, are you allowed to execute this kind of operation? Are you allowed to get patient records in general? You might be a doctor, so you're allowed, right? Like role-based authorization. And then, are you allowed to read this specific record of this patient, right? You might need to be the doctor of that patient to read the record. And maybe this person is in witness protection or something, and it has an address that no one should really read. Well, then that's property level authorization. We don't want to deliver out properties of everything to everyone. There might be different security issues with delivering properties to different type of roles in our system. So, but how do we really start with securing this endpoint that I showed? Well, we start at the functional level, the least specific. And for most of you guys, I think the normal way to start is with a policy-based approach. So this is .NET code, but it really applies to any programming language. There are ways to create policies for endpoints, and in .NET we just do authorize, and then we have created a policy that says you have to have this scope or this kind of claim in your JOT token. So that's okay, but to me, when this service is called, this looks very much like the parameter defense that we didn't want. Because once you're in here, you're really in, you can do whatever you want. There are no additional checks. So what happens if another endpoint calls this service and it misses this authorized attribute, or a service calls a service? We don't check anything here. And that to us is a real problem because code bases get messy and it's quite fragile, right?
Did you assume everybody will remember what you do, right?
Yeah, and there are a lot of developers, and I can't assume I remember what I did
You will remember
the next year. So how can we fix this then? We can think of a multiple layer approach, right? We want to secure the service in our application layer, and this we can do here. So let's say we do get the claim and we say that the claim should be a record to read. And we say no access to operation, and we say forbidden. You can't do this. And this looks good, but to me this doesn't look too good doing HTTP context stuff.
It's not
in
beautiful,
the
right?
service. It's not beautiful code, right?
No.
So, and it's probably not that secure either, because who's gonna remember someone's gonna misspell this or do something wrong with the claims, right? It's not very well modeled. So what we advocate for doing is creating abstractions for permissions. So we can make a permission service and we can say can read records, and this is very reusable for every part of code you have, because you probably have an endpoint or a service method that also returns a list of records, and then you can just reuse that. And you can test this and you can test the service. So how would this service look like? So the interface might look like this. This is the user ID. You can read, you can write records, and maybe some other stuff. And if we implement that, we have to implement the properties. And then we have to actually set the properties. Let's say we do it like this. We access the HTTP context and we get the user ID from the claim, the subject of the token. This is who the user is, right? Or some other claim if there is any specific OpenID Connect stuff. But then we can check, is this person in the scope? Then we set can read or can write. And we can add this as scoped. And in .NET, a scoped service means that it's instantiated once per request in an API. So we keep this as a context for the API request to make sure that it stays the same throughout the request, and we want a new check when a new request comes in. And this is exactly what is defense in depth. And I wanted to Google defense in depth because I wanted to know what did Google say defense in depth is. And I think it says exactly what we have done. They say defense in depth is a concept used in information security, which multiple layers of security controls are placed throughout an information technology system. Its intent is to provide redundancy in the event of a security control fails, and so on. So, right, we have created multiple layers. We have created redundancy. If we mess up in the policy, we have another layer that catches stuff, or the other way around. So by doing this, we're quite far in the functional level game. We are quite good at the functional level authorization. And if we create this pattern throughout the code, this will be a very good secure by design pattern. But I also want to talk about this one, the BOLA, the broken object level authorization, or hopefully not broken though. But this
often broken.
Yeah. This is the most often broken. This is top one, UVASP, and why do we always get this wrong? Because we know what happens. We are delivering objects that we shouldn't, and this one, can you see what happens here related to that? Anders?
It's something with the idea, maybe, what you're allowed to access?
Yeah. Because right now we are good with the functional level. We are checking it in multiple layers, but we will always return the record. We're not checking if anyone is actually allowed to see that specific record. And this is a typical insecure direct object reference. A very simple security bug, but so often implemented. So how can we fix this? Well, let's just look at the service. Let's just imagine we don't have the endpoint. We can implement a can read record method in the permission service. And we can say, okay, maybe a patient can read all record, user can read all records, then it's good, or you have to be the doctor of the patient. So you can implement complex logic here, you can test it, and you can reuse it. And then we make sure that even though you are allowed to read a record, we also check if you are allowed to read this specific record. So this, I think, is quite interesting. When do we really want to check for object level authorization? Do we want to do it before? Or do we want to do it after we fetch the data? And I'm going to get some code examples on how it would look before and how it will look after. Before, we can have a method and we use the patient ID. And after, we can, this is the get records, like a list. We can loop through the list and check if all the records are okay and remove those that are not. What would you do?
So how many would do it after? Only you? So all others will do it before then?
Yeah, why would
Our rest doesn't do it at all.
Yeah, why would you do it after then?
Because it's safer.
Yeah.
Do it before you can somehow sneak away, and once you get the record, you don't know it.
Yeah, exactly. You can do some sneaky way. But so let's see. Well, we always say fail fast is good, right? So this is good, and this might be okay, especially if we don't need to hit the database, right? But what happens in this one? Do we really have control over this method over time? Let's think about this slide. We have stress factors, and stress factor is code changes. And another developer might change that method, or something might happen to that. And what happens then if this suddenly returns something it shouldn't? Well, this way, we will return the records. So what we would advocate for is that in most cases, you could actually do both in simple cases. You can fail fast if you want performance, and that's good, but you can also be absolutely sure after you fetch the records that it's okay. So if we do this, we are quite good with the object level authorization. Not a lot can happen to us then. Property level, unfortunately, we don't have time to go that much into in this talk, but the number one thing is create specific DTOs or contracts so that you don't get mass assignment and that kind of stuff. But one other thing that I want to talk about is respect the user context, because I think I've seen this a lot in code. Well, you get patient records and we want to know who the doctor is, so we send in the doctor ID. But what we kind of miss is that this ID is very much controlled by the user. So then it's very easy to impersonate the doctor, right? Because the doctor is the one calling the API. And what happens then if we do this? Then the doctor, you can just be whoever you want, and then it's easy to read whatever you want. So if we look at the permission service, this line is very important. We always want to get the user ID from the context of the session, from the cookie session, from the token, from wherever the session data is.
Okay, good. So what are the main takeaways we want you to take from what we've spoken about now? First, most important is that good design leads to secure systems. We know for sure. And try to actually think about that and use it as when you will try to advocate for good design or doing design work. Remember that that's also security work most of the time. And again, there's no secure systems, so assume that you will be breached as soon as you deploy it. And embrace uncertainty. So again, you don't know what will happen. You don't know the changes that will come. There will be legal changes. There will be other developers changing your code. Try to think about that when you write it. Or again, then build systems for others to change, not only to work now and to you to go over to the next task. And then I just want to bring up this slide again. So in the beginning, we talked about antifragility and that we want to make anti-fragile systems, not only robust systems. And now I think we showed some techniques, some secure by design techniques that we at least think will lead towards anti-fragile systems. But there are lots of other things that you all already do that are towards this. So test-driven development is a very anti-fragile pattern. You want to do tests like a test on several levels, and that is to apply stress, right? But in a safe environment. DevOps, when DevOps was what it was in the beginning, these are the 3 ways of DevOps, what it used to be, and that's also towards anti-fragile. You want to have like smaller feedback loops. You want to deploy often to actually deploy or to get stress on your system as early as possible. And again, if you remember this graph, you want to deploy often to have that. I said that this top graph is actually not going just like that. It's going like up and down. And the shorter like deployment time you have, the less will the like hit you take be. And that's to be able to actually benefit from the stress you apply. That's pretty much what DevOps is about, in my opinion. And then we did have this funny thing. This is Netflix Chaos Monkey. I don't remember when, but it's probably like 10 years ago now. But yeah. That was very much this, since that was like this program that went around and shut off servers in Netflix infrastructure, exactly to apply stress and see, okay, what actually happens when when shit hits the fan. And now you have some very cool tools. I think in Azure it's called like Azure Chaos Studio. AWS has the same, it's fault injection or something like that, where you can actually make experiments to apply like very real stress and like take down servers and stuff like that, which is very interesting. So you can check that out. But again, we do lots of things already, so I kind of want to challenge you all to go when you go to work to actually see the things you do and try to think, is this actually towards anti-fragile systems? And I think you will see that it actually is. Or towards secure systems, if you think like with this secure by design mindset. Yes, so we just end on this slide. And now we have 10 minutes left, so we can take questions as well.
Yeah.
Thanks.
Thank you.
And we can take questions now, or we will be here, and remember to evaluate on your way out.
Yeah.
Yes.
Yes, about fragile and robust and anti-fragile system.
Yeah.
I like the graph. The axis that's missing is cost.
Cost.
Can you comment on that?
In what way you mean?
The way that making a fragile system is much cheaper and faster than making an anti-fragile one.
Is it?
Well, I would say the thing I said earlier, like, the question was about the cost. If you do a fragile system, it's much cheaper than doing an anti-fragile system, and it might be in the development cost, but if shit hits the fan and your system goes down, and you miss user interaction for like 3 days, and you're a web shop, then you might have a problem. You can lose like millions of dollars just in days, right? So I think it's a bit too naive to think that we will just cut down on security to get there. And it's not just about robustness and antifragile, right? This is security, this is integrity. It's very easily missed in the security business that the integrity of our system is just as important as the confidentiality.
But I think so when you mentioned proof of concept. But then I just want to emphasize again that when I think about this, I think about, so if you're at a company, I think that the main system you want to be anti-fragile is the sum of all the systems in the company, not like one piece. Since of course, when you make a proof of concept, you can't spend time on doing all. That's just then you have simpler design, right? That might be fine since the risk is so low. That makes sense.
Also, I would say doing some of these design approaches that we did, if you are able to do them from the beginning, it's not much more work. I can see that it's much work applying them after the fact, but most of these patterns you can just start using and then transition the new code into those. And it's better to have a domain primitive that you know is very much valid everywhere than checking it for null and doing regex expression in every class everywhere and having to test every different kind of data.
But I think it is actually a discussion.
Yeah.
So we have that internally a lot of time, especially with like these patterns. So and domain primitive is a good one, and it's in the DDD Blue Book. This is mentioned a lot as well, and they say like focus on core domain, right? So in your core domain and like your money domain, there you should probably do everything, right? But on like the fringes and like for the MVPs and like the experiments you do, then probably not. But then some at our company at least, they advocate for like, okay, they will never use a string at anything. It will be like domain primitives everywhere, and you should do that like all the way. But then their argument is that, as Eivind said, if you do it from the beginning, it isn't really a big cost, since most of these are very simple classes. But that is up for discussion. I agree. Anyone else?
Question about the functional level authorization that you were showing. Could you explain again why is it the downside to authorize based on decorators of a method? Because you showed first the decorator authorize and then you specify a policy. Then you say, oh, this is problematic. Why is that?
Yeah, so it's about the functional level programming, why it's problematic to decorate the class with a policy. Yeah, well, I wouldn't say that it's problematic. I say it's very good to do that, but it's not enough to just do that. And I would always use policies to check for permissions. But the thing is that your API layer, you might have an API layer, and then you have something where a service bus comes in, and then you have an integration, and there are lots of entrances to your system. So the application layer, which handles everything, should also be aware of the functional level authorization, who is allowed to do what, so that you don't create this big trust boundary. You should create more zero trust in your system. But yeah, of course, I would have both layers.
But I think the service bus example is good.
Yeah.
Since you often will actually have like different APIs, different API interfaces, like web API is one, and then service bus is another. They will often use the same like service classes. And if you only have it there, then you suddenly have a vulnerability through your service bus.
Or an inconsistency in how you check your authorization.
People love the graph.
I was just curious how, if you could give an example of how the performance actually increases with increased stress. I can see that from these examples.
Okay, so then we need to say again that what performance. Okay, so the question was a concrete example of when the performance actually increases with the increased stress, right? So I don't know if I have a spot an example, but we need to emphasize that the performance is again the sum of everything. So it can be like how fast you find bugs, I think maybe bugs is the best. So, and if you think about test-driven development, I think that's a good example. So you will find bugs, and if you write a test for every bug you find, which you should do, right? Then you ensure that the bug will not come up again later. I think that's one. Then the performance will be better since you will have less and less bugs with more and more stress. So in the beginning, when you deploy your system, for day one, you will have lots of bugs. And then when you increase stress, more and more users will find more and more bugs, and you will get like less in when you go over time. That's just from my top of my head.
Yeah, and the important thing here is that in one instance of time, if you apply more stress, of course the system will probably perform worse, but this is stress over time, like we'll learn from the stress that is applied.
I would just imagine that it would level out at some point, not continue exploding.
Yes, of course.
Probably, but
yeah.
there will always... Yeah, so the thing is, you said it will level out over time, but there will always be new exploits and new ways to think and new vulnerabilities in the packages you have, and so you will always have to maintain the system. And it's the same as the pandemic. If you have no users for a year, probably your system performs worse after.
Even if you don't see it in the instant of time. So. But again, this is like philosophy, right?
Yeah.
And it's like terms. So it's nothing more than that, unfortunately.
Can I just comment on that?
Yes, please.
I think that instead of performance, the word should actually be quality. So once you stress and find all the bugs,
Yeah, maybe.
Yeah.
the quality of your product or the stability of your product increases. So it's not performance like in milliseconds or
No, of course not. So yeah.
Yeah, so the suggestion here is to call it quality instead of performance, which I think might be a good suggestion, which make it more clear since performance is kind of overloaded term.
Yeah.
Quality works if you don't consider it a business.
What? Again? Come again?
Quality works as a metric for that graph if you ignore there's a business you're running.
Yes. Yeah. Okay. So then performance is better. Since the comment here was that quality works if you ignore that you have to make money. In a way, it's a business. So then maybe performance is better again.
Yeah, so it's just words, like we have to kind of philosophize.
But this is the good
around
thing,
them.
since
But
it's good
very
discussions
that,
on this. Yeah.
Yeah.
Okay.
Anything else, or I think we'll round off.
End it here, and you have 3 minutes for extra break.
Yeah, and please remember to evaluate on your way out and come talk to us throughout the conference. We're here and are happy to discuss anything from the presentation or anything else. Thank you.